You know that very specific type of satisfaction you get when you finally figure out a shortcut.
Oh, man, absolutely. Like a little dopamine hit.
Right. And I don't mean just, finding a faster route while driving. I mean when you're in the middle of a process.
Really tedious process.
Yes. Maybe it's a complicated spreadsheet you're wrestling with, or maybe it's just the way you chop vegetables for dinner. But you realize that if you just tweak one tiny, almost invisible variable, the whole thing suddenly moves like twice as fast.
It is the best feeling. It's
No.
the moment where all the friction just sort of evaporates, the gears lock into place, and you're left with pure flow.
Exactly. It's the need for speed, but it's more than just going fast for the sake of it. It's about respecting your own time enough to stop waiting for things to happen. And that is exactly the theme of our deep dive today.
It really is.
We are looking at a fascinating case study. On the surface, it looks like a very technical tutorial, but underneath, it's basically a philosophy for living.
Yeah, we're digging into a blog post from February 25, 2026. It's titled Notes on Haskell Programming, Part 67, Parallel Execution with hspec-discover.
Part 67. That number alone stops me in my tracks.
It's commitment.
Right. This isn't a casual, here's a quick tip I found online kind of article. This is a saga. This is someone who has been rigorously documenting their journey for a long time.
It's a massive archive. The author is a developer named Eng-Kian Meng. He writes at qianemeng.org, and he refers to himself by a title that I think really frames our entire conversation today. He calls himself an old software plumber.
I love that title. Software plumber. It's
Oh, yeah.
humble, isn't it?
Very grounded.
It's gritty. It implies that he's the guy keeping the pipes from bursting while everyone else is upstairs looking at the shiny faucets or the interior decorating.
Precisely. It implies a focus on utility, on maintenance, and on making sure things flow correctly behind the walls. And in this post, he's fixing a leak in the testing process.
Which sounds incredibly niche, but stick with us.
Exactly. While the specific topic is about the Haskell programming language, the lesson he unearths is universal. It's about the danger of accepting default settings, the critical importance of benchmarking actually measuring things, and the massive hidden power of parallelization.
And just to give everyone a reason to stay glued to this deep dive, we're talking about a one-line code change that resulted in a 56% improvement in speed.
56%.
I mean, if I could get my coffee machine to brew 56% faster or my laundry to dry 56% faster, I'd be a significantly happier person.
We all would. But to get there, we have to understand the bottleneck. We have to understand why things were slow in the first place and why the default setting was holding him back.
So let's set the scene for you. Ang is working in Haskell. Now, for those who aren't coding daily, Haskell is known as the math professor of programming languages, right? It's robust, it's logical, it's very strict.
That's a very fair characterization. Haskell relies heavily on correctness. It's not a move fast and break things language. It's move deliberately and prove it works language.
Makes sense.
And because correctness is so important, testing is everything. You don't just write code. You write extensive tests to prove the code does exactly what you say it does.
Okay. And the tool Ang is using to manage all these tests is called hspec-discover.
Right. So imagine you have a massive library of books. That's your code. You have thousands of books. hspec-discover is like the librarian whose sole job is to walk through the stacks, find every single test case you've written, and put them in a pile to be executed.
Useful. It automates the discovery process so you don't have to manually list every single test file.
Exactly. It saves a lot of manual labor.
So it finds the tests. What's the actual problem?
The problem isn't finding them, it's how it runs them. As Ang points out in this post, the default behavior of hspec-discover is to run the test suite sequentially.
Sequentially. Single file. One at a time.
Exactly.
Okay, I want to use an analogy here to make sure we really grasp the pain of this. This feels like the grocery store on a busy Sunday afternoon.
Oh, I hate Sunday grocery shopping.
Right. You got 10 registers available, you have 10 customers ready to pay, carts totally full of stuff.
Yeah.
But the store manager, that's the software, decides, you know what? We're strictly a lane 1 operation today.
That is the perfect analogy. Everyone has to line up in lane 1.
So the first person has to scan all their items,
Yeah.
haggle over a coupon, pay, and bag their groceries before the second person can even start putting their stuff on the belt.
And it's actually worse than that in computing, because in the grocery store, the other cashiers might be on break or stocking shelves. In your computer, the cashiers are your CPU cores. Modern computers have multiple cores, multiple brains sitting there ready to work.
Just wait.
If you run sequentially, you are forcing every customer to wait while 90% of your computer's brain power is just sitting there twiddling its thumbs, doing absolutely nothing.
It's strictly lane 1, while lanes 2 through 8 are completely empty and the cashiers are just staring at the ceiling.
Exactly.
And Aang noticed this. Now, this is where that software plumber personality kicks in, because most people would just think, this is a bit sluggish, and go grab a coffee or check their phone.
Right. We just get used to the wait. We accept the friction. But a plumber investigates the pressure drop. He didn't just guess it was slow. He decided to prove it. This is the scientific method in action. He established a baseline figure.
He brought receipts. He wrote a bash script, basically a command to the computer to run these tests not once but 5 times to get a reliable average. Why 5, though? Why not just run it once, look at the clock, and say, aha?
Because computers are noisy environments. It's like timing a sprinter on a track. If the wind blows, or if the sprinter trips, or if a dog runs onto the field, the time is off.
Too many variables.
Exactly. In a computer, maybe a background update starts, or the hard drive spins up to index a file. If you run it once, you might catch an outlier, a complete fluke. Aang ran it 5 times to smooth out the noise and get a statistically significant average.
Smart. He's removing the luck factor. And here is the baseline data he got for running his tests sequentially. 0.00234 seconds.
0.002 of a second.
Okay, I have to play devil's advocate here. I'm looking at that number and I'm thinking, really? We're holding a deep dive over 0.0002 seconds. That is faster than a blink.
It is incredibly fast, yes.
It's faster than a synapse firing. Why does this matter? Why would a plumber even bother fixing a leak that small?
I'm really glad you asked that because it's the most common misconception in performance tuning. You have to look at context and scale. First, Aang mentions this is a pet project. It's small. Real-world enterprise applications can have thousands or tens of thousands of tests.
So that 0.002 seconds scales up.
Linearly, at best, sometimes exponentially. If you have 10,000 tests running sequentially, those milliseconds turn into seconds, then minutes. Imagine waiting 20 minutes every time you want to save your work just to see if you broke something.
Oh, that completely kills your flow.
Completely. It's what we call context switching. If the test takes 0.002 seconds, it's instantaneous. You don't stop thinking about the code. If it takes 20 minutes, you tab over to Reddit, you check your email, you go get a snack, and suddenly you've lost the entire mental model of the complex system you were building.
You forget what you're even trying to do.
Exactly. For a developer, speed isn't just about time on the clock. It's about maintaining a state of cognitive flow.
So for a software plumber, that 0.0002 seconds isn't just a number. It's a symptom. It's a leak. It's a sign of inefficiency that will eventually cause water damage if you don't fix it.
Spot on. It's about the principle of the thing.
So he has his baseline. He knows lane 1 is the bottleneck. He sees the empty lanes. How does he get the manager to open them?
This is the elegant part. He doesn't have to rewrite his whole application. He doesn't need to buy a supercomputer. He uses a feature built into the tool called a hook.
A hook? That sounds vaguely piratical.
In programming terms, think of a hook as a sticky note you leave on the manager's desk that says, hey, before you start the day, read this. It allows you to intervene in the standard process. It intercepts the command before it executes.
And what did the note say?
He created a file named test-spec-hook.has. And inside, he basically wrote 2 lines. He put import test.hspec and then defined hook equals parallel.
That's it. Hook equals parallel.
That is the magic spell.
That feels suspiciously easy. It almost makes you angry. If it's just a declarative change like that, why isn't that the default? Why are we suffering in lane 1 if hook equals parallel exists?
That is the million-dollar question. The reason sequential is the default is safety. Remember the grocery store. Imagine if 2 customers tried to pay at the exact same time using the exact same card reader. Total chaos. The system crashes. In programming, that's called a race condition. If 2 tests try to change the same database entry at the exact same time or write to the same file, they crash. Sequential is slow, but it's safe because they politely take turns. Parallel is fast, but you have to be sure your tests don't step on each other's toes.
So Aang knew his tests were independent. He knew they could shop in different lanes without fighting over the same cart.
Exactly. And because he works in Haskell, which we mentioned is very strict and mathematical, it's actually much easier to write safe parallel tests than in other languages. Haskell naturally discourages shared state, which is the digital equivalent of fighting over the same cart.
Oh, that's interesting.
So he just had to declare his intent. Hook equals parallel. He didn't have to micromanage the threads manually. He just told the system how to behave.
So he flips the switch, the sticky note is on the manager's desk, lanes 2 through 8 are open, he runs the benchmark again 5 times, naturally because we are being scientific. What happened?
A numbers drop, a massive drop.
The new average execution time is 0.000102 seconds.
So we went from roughly 2.3 milliseconds down to 1 millisecond.
Which, according to the math in the post, is a performance improvement of approximately 56%.
56%. Think about that. He reclaimed more than half the execution time with one line of code.
And again, on a pet project, saving a millisecond is trivial. But if you apply a 56% speed boost to a massive enterprise test suite that normally takes an hour, you just bought yourself a 30-minute lunch break every single day.
That is the real return on investment. The time it took him to write hook equals parallel was maybe 10 seconds. The time saved over the lifetime of the project is astronomical. It's one of the highest leverage things you can do.
Ang's reaction in the post is just pure developer joy. He writes, "Isn't it fascinating how such a small change can make such a big difference?"
And that question captures the essence of what we do. We often think that big results require big, sweaty efforts. We think we need to tear the entire house down to fix the plumbing. But sometimes you just need to know which tiny valve to turn. It's knowledge over brute force.
It really makes you wonder what other default settings we are living with that are secretly slowing us down.
It does. But I think to really understand why Ang found this and why he bothered to document it so carefully, we need to shift focus from the code to the coder. We have to look at the person behind the keyboard. Because I spent some time clicking around the About section on kianmang.org, and wow.
Oh, the sidebar. We have to talk about the sidebar.
This isn't just a coding blog. This is a digital museum of a man's curiosity, a true Renaissance man.
He really is. He calls it the Journal of an Old Software Plumber, which suggests a focus on code. But then you start scrolling through the categories.
Tell us what you found.
Okay, so we have notes on Haskell Programming, obviously. That's part 67. But right below that, notes on gardening.
Gardening, okay. Nice hobby to get away from the screen.
And not just a few tips on growing tomatoes. We are talking about, let me check my notes, over 800 parts.
Wait, 800 blog posts about gardening?
Yes, part 818. The search for the part 815, why your variegated plants are reverting. It goes on for pages and pages.
That is astounding consistency. That is years of daily work.
Well, wait, there's more. Notes on fish keeping. Over 200 parts. Part 202, will guppies eat? Part 191, identification.
This paints a very specific picture of who we're dealing with here.
And it keeps going. Notes on dieting, notes on guitar, notes on meditation, notes on home improvement. There's even a category called betta spawn logs.
He logs the spawning of his betta fish.
He logs everything. In February 2026 alone, the month this Haskell post was written, he published 75 posts. That is more than 2 a day, every single day.
That is incredible. You know, we often stereotype people in this industry. You're either the tech guy who lives in the glow of a monitor in a dark room, or you're the nature person who gardens and keeps fish and avoids technology. We treat them as opposite ends of the spectrum. But Ang is proving that the mindset is exactly the same.
How do you mean? How is parallelizing a Haskell test like keeping guppies?
Think about what a gardener actually does. A gardener observes a system. It's a biological system, sure, but it's a complex system. They notice a small variable change, a yellowing leaf, a dry patch of soil. They make a tweak, add some nitrogen, change the watering schedule, and then they wait and observe the result.
That sounds exactly like running a benchmark test.
It is exactly the same loop. My test suite is slow is the exact same problem as my coleus plant is wilting. You identify the bottleneck, you apply a hook, whether that's a line of code or a specific fertilizer, and you measure the outcome. The fact that he has over 800 notes on gardening and 67 notes on Haskell tells me that he applies this rigorous plumber mindset to every single aspect of his existence.
It's a philosophy of consistent incremental improvement. He's not just debugging his code, he's debugging his aquarium. He's debugging his garden. He's looking at his guitar practice and thinking, how can I optimize this flow?
And most importantly, he is documenting it. That's the software plumber part. He's leaving a trail. He notes that he spends his nights tinkering with FreeLibre and open source software Flossess. He believes that knowledge, whether it's about parallel processing or plant propagation, should be shared.
It really redefines the word plumber, doesn't it?
It elevates it.
I usually think of a plumber as the person you call in a panic when things go wrong and there's water everywhere. But in Ang's world, a plumber is a steward, someone who takes care of the systems to ensure they flow correctly. He's maintaining the infrastructure of his life.
Stewardship is the perfect word. And think about the discipline required to write 75 posts a month. Most of us struggle to write one journal entry. He is constantly processing, measuring, and sharing. That 56% speed up he found, he didn't keep it to himself. He wrote it down so that some other developer will find it and save themselves an hour of frustration.
That is the beauty of the open web. It connects the old software plumber in one corner of the world with a struggling learner in another, all through a text file. So let's wrap this up and distill the key takeaways for you listening right now. We started with the need for speed. We looked at how Anki and Meng took a sequential process, applied a simple parallel hook, and boosted efficiency by 56%.
We learned that default settings are often there for safety, not performance. Running sequentially is safe, but it leaves your resources idle. If you want performance, you have to be willing to look under the hood and ask, can we do this in parallel? You have to be willing to challenge the default.
We also learned the absolute necessity of the baseline. You cannot improve what you do not measure. Aang ran the bash script 5 times before he even touched the code. He relied on the stopwatch, not his feelings.
That's a discipline we can all apply, whether we're coding or trying to cut time off our morning commute.
And finally, we just have a deep appreciation for the dedication to tinkering. The hacker mindset isn't just for computers. It applies to gardening, to fish keeping, to everything. It's about noticing the details that everyone else ignores and caring enough to fix them.
It's about reclaiming your time. Which leads me to a final thought to leave you with. In your own work or life, what default setting are you accepting simply because it's there? If you ran a benchmark on your daily routine, where could you apply a parallel hook to reclaim 56% of your time?
That is a phenomenal question to chew on. Huge thanks to the old software plumber Anki Meng for the lesson in code and in life. And thank you for joining us on this deep dive.
Check your defaults and keep tinkering.
Catch you next time.